Hey guys, I wanted to create a short little video to see if I could help you with the indirect addressing approach for the project. So if you're not planning on using indirect addressing, you just kind of want to go for the middle of the road, which is fine, then this video is not for you. This is for those who are trying to implement a more, say, elegant approach to solving this problem. And I just wanted to give you a little bit of a heads up or a little bit of a clue as to how indirect addressing is used. So I'm going to start with this program that you see on the screen that you see on my Teach Pendant. So what does this program do? This program indexes the register value in data register 1 called program select. It indexes it 1 unit at a time until it cycles through all 3 shapes. And then once its value becomes 4, meaning it's equal to 4, then it doesn't loop any longer, then it just ends. So if we run this program, and this runs real fast, but it will run each of the shapes, and then it returns back to the main program. All right, so that's one way to do this. So this is not indirect addressing, but I wanted to start here to see how we might be able to implement indirect addressing or incorporate indirect addressing into a program like this. This is, by the way, this is not the approach that I took for the project. This is just an example problem to give you an idea of how you could use indirect addressing. So if you want to know what I did for the project, I did use indirect addressing, but I used it to keep up with the cycle counts. Right? So how many times the circle ran, how many times the square, how many times shapes ran. So I used indirect addressing to keep up with the cycle counts. And I also used indirect addressing to keep up with the timers, the timer identification. So I dumped the value of the timer into a register, and I indexed that register as I progressed through the program, and I indexed that using indirect addressing. All right, so let's try to peel the veil off of this thing called indirect addressing. All right, so if we have this program in front of us that just cycles through this data register R1, and it just changes the value of R1 to 1, 2, and then 3. It's pretty straightforward. But there is another approach to this. So I can use indirect addressing to establish another means of selecting these programs. So the way I would do that is I would, instead of using a select data register constant, I might put an indirect data register reference here. So right now the program is looking at the value in R1. It's looking at the value in R1, and it's comparing that to what it has here, 1, 2, or 3. If it's a 1, 2, or 3, then it runs those programs. And if it's not, then it just keeps jumping. But we could use an indirect addressing approach here. Now here's how you would do this. Instead of using a single register to select program number 1, 2, or 3, you would use a dedicated register for 1, a dedicated register for 2, and a dedicated register for 3. And then you would just index those registers. All right, so let me show you what I mean by that. So first of all, we need to establish this collection of registers that we're going to be cycling through. So we're going to cycle one at a time through data register, the first one, second one, and the third one. All right, so we need to pick a set of data registers. And for me, I'm just going to pick a high number on my data registers. I'm going to start at 51, and I'm going to assign 51 value of 1, then 2, then 3, right? So there's my collection of 3 data registers. All right, and then I'm going to establish this data register program select equal to 51, because that's my first data register that I'm going to be using. I'm going to be using data register number 51. And then I'm going to be using program select instead of using the value in program select to call these programs. I'm going to use the value in register 1 basically to call another register. Now, it's not technically a call on the register. It is what we refer to as indirect addressing. All right, so we're going to need to change this to indirect. So that's going to be indirect. That's going to be 1. So that center value is still register 1 program select register, but now it's no longer the value that we're looking for to control which program we call. It's just the reference number now that we're going to use to call the register, not to call the register, but to compare the register values in order to run either programs 1, 2, or 3. All right, so if I run this program right now, it's going to run, it's going to say, what is the value of register program select? Now, program select is set at 51. It's going to look at the value in register 51. It's going to know that it's going to see that it's 1, and it's going to run the circle. And then that's all that's going to happen. This program select plus 1 will index, and then program select plus 4, less than 4, will jump label. This will not happen, right? So here's the next problem. So if I just stop here, it's going to run circle once, and then it's going to get here and it's going to say, is program select less than 4? No, it's not less than 4. Program select is 51. We start out at 51. So we have to change that. So we're going to have to add another register, another counter in this strategy in order to make this work. So let's go ahead and do that. We're going to need to insert a line here. And we're going to need to insert a line. Let's just go above there. A line there. One line there, one line there, to keep up with this new register counter. So we're going to use equals. Actually, we're going to use equals plus 1 because we're going to need a counter. And register. And I'm just going to reuse a counter register that I've already used. And that's going to equal register counter number 3 plus 1 constant 1. All right, so now I've got a counter, and then I need to change this to counter. So this is now going to be my counter. Program select is no longer my counter. I'm using a different register to control my counts, and I'm going to let program select maintain its job of just selecting the correct data register to compare when using this select function. All right, so let's go back up to the top. We have to also declare our data register value in counter. That's 3. And we want that equal to a 0 for starters, so that it counts. All right, so now if I play this, what's going to happen the first time I go through this program? It's going to set that to 0. It's going to set that to 51. It's going to say, if the value in data register 51, this is data register 51, because I set the value to 51, is equal to 1, call the circle. If it's equal to 2, square, and 3, triangle. And then it's going to see that it's 1, so it's going to call the circle. Then it moves on, and it indexes by 1. So now we have the value in program select equal to 52. And we're going to count. We set the counter at 0 at first, so this is the first one, so it becomes 1. And it says if it's less than 4, jump label 1. So now it comes back for the second loop. In the second loop, my program select value is now 52. So it's going to look at register number 52, and it's going to run the program that's assigned to 52. So in this case, I could run 3 circles. I could run a circle and 2 squares. I can run 2 squares and a triangle, any combination that I want, depending on how I set the values for data registers 51, 52, and 53. So that's how it works. We'll push the play button, make sure that this goes okay. So what we should get is circle, square, triangle, and stop. And that's the way it works. So give it a shot. If you run into problems and you still want to persist with that, then I want to encourage you to try to do that. And I'll answer any questions that you have. If not, just kind of fall back to a more pure counter program and skip the indirect addressing. All right, good luck.